Good evening and welcome again to my science channel. Now last time we looked at the Monostable Multi-vibrator where you had a free running square wave output, but today we're going to look at something different. Once again it's going to be a multi-vibrator, but it's going to be a monostable multi-vibrator. So if we have a look at the circuit I built on this breadboard, I'll give you a little demonstration of what it looks like when it's in use. And these things are used in devices such as timers and things like that, and that'll become obvious when we have a look at the function of it. This is the circuit. Once again we're using the 555 timer chip. Now we've got a little switch here, and what's very important is this capacitor and this resistor. So once again we're using these two components for timing, and we'll do a little calculation on that later. But if I operate this switch here, what we'll see is the LED light up and stay on for a period of time after I release the switch. So we pulse the switch and then we have the LED coming on. And the length of time that that stays on is dependent on the capacitor resistor combination. Let's put this on the oscilloscope so we can see what's going on with the circuit. Now if we look at the oscilloscope, I've got channel 1 connected to the switch and channel 2 connected to the output. So if I trigger the switch, what we can see is a very short pulse there going downwards, and that's staying high for an amount of time before returning to the monostable state. So it's monostable there. I give it a trigger, and it's known as a falling edge trigger, which raises it for a period of time, and then the output falls back to the stable state, as you can see there. Quick trigger pulse, and then that goes high for a period of time and then falls back to the stable state. This is the circuit. We can see our 555 timer here. Now what we have is this 10k resistor. Now this is a pull-up resistor. So when this switch is open, this is holding this at a higher voltage. It's not going to 0 volts. Because when the switch goes to 0 volts, if you remember when we were looking at the demonstration, we said that it was a falling edge device. So when we close that switch, this pulls this down to 0 volts, triggers the device to enter the monostable period. And then that monostable period is dictated by the value of that resistor and that capacitor there. So this is what was happening on the oscilloscope. So you've got the trigger. So this is where we do the switch. So the switch is held high at 9 volts. When we trigger the switch, it briefly goes down to 0 volts and then back up. But what we start at the output is the monostable period. So you can see if we follow this along, at the period when the switch voltage drops down to 0, that's triggering the device, it initiates the time period, the monostable period, and we can actually calculate this period. Now that monostable period that we looked at, the calculation is the T, so that's time, is equal to 1.1, which is a constant, multiplied by the value of the resistor, multiplied by the value of the capacitor. Now let's apply this calculation to the actual circuit that we were just using, and we will come up with this. So on that circuit, we brought this formula in. T is equal to 1.1 times the resistance times the capacitance. So that's 1.1. Now we had a 5.6k resistor, so that's 5,600 ohms, multiplied by the value of the capacitor. So it was a 100 microfarad capacitor, so it's 100 times 10 to the minus 6, and if we just plug those values into our calculator, we come out with a time period of 0.616 seconds. And if you remember that when we instigate the monostable period, the LED stays lit for just over half a second. So this actually works, so that's about right. So I hope you enjoyed that on the little monostable multi-vibrator. Now we've previously looked at the astable multi-vibrator, we've looked at the monostable multi-vibrator, and there's one left which is the bistable multi-vibrator. So that'll be coming up in my next film. Hope you enjoyed that. Please like and comment and subscribe. If you'd like me to see me doing any particular topic, shove it in the comments and I'll do my best to get it done.